Hello everyone, welcome to Aaron. So now we solve this question based on Bayesian cycle, where we have been given the dimensions of the cylinder, and we have been given the compression ratio, and we have been given a condition that the injection of fuel is done for 10% of the stroke, and we have been asked to calculate the efficiency. So let's see how we can solve this question. So firstly, we have like if you look at a geometry of the engine, so let us consider it as a cylindrical engine, which is many times it is considered as the cylindrical geometry only. So you have a 95 mm as the stroke. The stroke is nothing but the distance between the top dead center of the engine and the bottom dead center of the engine. So this should be the stroke length. It is said this is stroke length. And the bore is nothing but the diameter of the cylinder, or the diameter of the piston also, which is nothing but 100 N. So this is the diameter of the cylinder. We have this volume, which is as the clearance volume. So this is as the clearance. This is where the combustion of the gases will happen, and this volume will always be constant. It does not matter on the crank angle or because the crank or the piston will move towards TDC and then will move downwards toward VDC. It will not go up towards the top of the cylinder. So V clearance will always be there. V strut will be keep on changing depending on your the crank angle then. So what I will to say here is that let us see you have a piston at the bottom dead center, and then you move it upwards up to the top dead center. So what we have done, you have just compressed the air which was there in the cylinder at the volume of the volume clearance. So the volume before the compression was volume clearance was volume swept. So the volume which is nothing but the for the stroke length is also called as the stroke volume or the swept volume, and the volume clearance is different. So divided by the volume after the compression becomes volume compression, or sorry, volume clearance. So this terms, which is nothing but volume before compression divided by volume after compression, is nothing but known as compression ratio. So this is a basic concept which you need to understand first, that the volume before compression was the volume swept plus the volume clearance, and after the compression it just is volume clearance because the volume swept will become zero. So you can easily solve this question if you get this concept. Firstly, you just need to calculate volume stroke, which will be pi by 4 into d square into L. So L is the stroke, d is the bore given. So if you calculate this, see it comes out to be like pi by 4 into dA is been given as 100 mm. You can just take it in centimeter, which is 10 square into L is 9.5. So it comes out to be 746.13 centimeter cube cc. So cc is the common unit you describe the volume of the cylinder as cc. You must have heard it describing the engine of the volume of the engine is like 350 cc and 450 cc like that. So 746.13 cc is the volume of our swept engine. But we need to calculate the clearance volume also, because this volume is nothing but swept volume. So you can use the compression ratio for that. You have 1 plus Vs by Vc is equal to compression ratio as 23, as given in the question. We have Vs by Vc as 22. We have Vc as 746.13 divided by 22, which comes out to be 32.44. Well, let us calculate it once again. We have 746.13 divided by 22, 33.9. Sorry, so this should be 33.9. So let us move ahead. We have in the clearance, we have got it as 33.9. So let us just write as V stroke as 746.13 and V clearance as 33.9 cc. So both of these volume were necessary to calculate first, because further going into the question, you will understand that these are required in order to solve the entire question. So in order to calculate the efficiency of any, what are the terms that you need? So you will get it from the formula of the efficiency, that it is nothing but 1 minus 1 divided by r to the power gamma minus 1 into like alpha to the power gamma minus 1 divided by gamma into alpha minus 1, where alpha is the cutoff ratio of the wave. So alpha is the cutoff ratio, and we have gamma as the isentropic coefficient. So isentropic coefficient, we have r as the compression ratio. So this is nothing but the compression ratio. So we have been given the compression ratio. We know the gamma value as a 1.4 for any cycle engine, but we only need to find the alpha. So how can we find it? So if you assume that the combustion starts at the TDC and goes on, or it is given in the question that the injection of fuel is done for 10% of the stroke. So if you assume that the injection starts at the TDC and it goes on until the 10% of the stroke. So 10% of the stroke means 10% of the clean swept volume also, because the total stroke is the total swept volume, and the 10% of the stroke will mean 10% of the swept volume. So what does it mean? That the cutoff ratio, the definition of cutoff ratio is nothing but the volume after combustion process divided by volume before combustion. We have volume after combustion as V clearance will be always be there, plus 10% of the V swept, and we have volume before combustion as the V clearance only, because that is when we are started to injecting the fuel, and after we are we are injecting it 10% of the stroke and then we are leaving it. So that will be the total duration of the combustion. So 10% of the stroke we will stop injecting the fuel, and that is the volume will be after the combustion process or the end of the combustion process, and the combustion will start at the TDC where the only the V clearance will be there, and then will be zero V swept volume. So if you calculate this, you will get it as 33.9 plus 10% of this will be 74.613 divided by VC will be 33.9, and the cutoff ratio will be 33.9 plus 74.613 divided by 33.9 should come out to be 3.2 as your cutoff ratio. So if you put this cutoff ratio into our original equation, which was this efficiency equation, you can solve this to get the efficiency value. You have efficiency as 1 minus 1 divided by R value is 23 to the power 0.4 into alpha is 3.2 to the power 1.4 minus 1 divided by 1.4 into 2.2. Sorry, this is 2. So let us calculate that. We have 3.2 to the power 1.4 minus 3 divided by 1.4 into 2.2 divided by 23 to the power 0.4. 1 minus that is 62% will be your cycle efficiency if you calculate using this formula. So this is how you can solve this question. I think